When you hear the words nuclear engineer, what's the first thing that pops into your head? Probably a power plant, right? A control room filled with dials? Well, get ready, because we're about to completely shatter that image. We're going to dive into the surprising, super diverse, and frankly, world-changing reality of what a nuclear engineer actually does. Okay, so the very first thing you need to know is this. That stereotype of one single type of nuclear engineer, it's just wrong. This is an incredibly varied field, and these engineers are tackling some of humanity's biggest challenges in areas you'd never, ever expect. So, let's get right into it. If it's not just one job, what are they actually solving? What does a day in the life truly look like? Well, it turns out the answer completely depends on the problem they've decided to solve. I love this quote from a Reddit discussion between nuclear engineers because it just absolutely nails it. They work everywhere. Power plants, sure, but also national labs, the Department of Defense, even space agencies. They're doing everything from designing brand new reactor cores to developing advanced radiation detectors for homeland security. The field is a whole universe of different roles. All right, let's start with the one you're probably most familiar with, energy. The push for clean, reliable power is one of the biggest challenges of our time. And yeah, you guessed it, nuclear engineers are right there on the front lines. So here's the critical question. How do you harness the incredible power of the atom safely? The problem of managing radiation is where a really specific expert comes in. Meet the shielding engineer. You can think of them as the architects of safety. The job of a shielding engineer is just crucial. They build these incredibly complex physics models to predict exactly how radiation will behave. Then, they use those models to design the physical shielding that protects everyone, from workers inside the plant to the public outside. And they don't just guess, they run tons of simulations and then have to prove to regulators that their designs are fundamentally safe. Okay, so we've covered powering our world. Now let's completely switch gears and talk about exploring new worlds. Because it turns out, the exact same principles of nuclear engineering are absolutely essential for pushing the boundaries of space exploration. What you're looking at here is basically Earth's protective magnetic bubble. It shields us from all sorts of nasty stuff from the sun. But the moment a spacecraft leaves that bubble, it's exposed to a brutal radiation environment that can fry sensitive electronics and pose a huge risk to astronauts. So, there's the problem. How in the world do you protect our delicate technology and our astronauts from this invisible storm of high-energy particles? Well, the solution is another specialist, the radiation effects engineer. These engineers, like the ones working for the European Space Agency, are pretty much the guardians of our space missions. They'll test every single electronic component to see how it holds up to radiation. They run simulations to predict what will happen out there, and they develop what's called radiation-hardened technologies, which is basically just electronics with built-in armor, designed to survive the crazy environment of space. And this isn't just some abstract idea. This is real-world stuff. Take nuclear engineer Haley Green. She worked on a NASA-sponsored project to figure out the best way to protect astronauts living on the moon. She was using simulations to figure out the perfect materials to shield a lunar base. That's nuclear engineering making future space colonies possible. So we've powered Earth, and we've planned for space. But the impact of nuclear engineering also gets a lot closer to home in a really personal way. We're talking about saving lives. As Haley Green says right here, the ability to cure cancer is one of the most powerful benefits of nuclear medicine. And who do you think makes these revolutionary medical treatments possible from the very beginning? Nuclear engineers. The best way to think about it is like this. Engineers use a special research reactor to essentially cook up very specific, medically useful atoms called isotopes. These isotopes then become the active ingredients in things like advanced medical imaging and powerful cancer-fighting drugs. A perfect example is Haley Green's work at Oak Ridge National Laboratory. She helps design these special targets that go inside a reactor specifically to create ultra-pure carbon-14. Now, this isn't the stuff you find in nature. It's a super specialized medical-grade version that is absolutely essential for making certain life-saving drugs. They are literally creating the building blocks for modern medicine. But here's the thing, whether we're talking about powering cities, exploring space, or creating medicine, there is one principle that underpins everything: safety. And that responsibility is so important. It requires its own dedicated experts. So, meet the Radiation Safety Officer, or RSO. This person is the ultimate guardian of safety in the nuclear world. Their entire job revolves around a simple but powerful principle known as ALARA, keeping radiation exposure as low as reasonably achievable. They write the rule book, they train every single person on site, and this is the most important part, they have the absolute authority to stop any activity they think is unsafe. They are the essential check and balance for the entire field. Okay, so after seeing all this, you might be thinking, you know what? I want to solve problems like that. Whether it's clean energy, space exploration, or medicine that gets you excited, there is a clear path forward. The journey usually kicks off with a bachelor's degree in nuclear engineering, where you can often specialize in cool areas like radiological engineering or medical physics. Getting hands-on experience is huge. A lot of universities even have their own research reactors where students can learn to operate one themselves. And if you want to get into advanced design or research, going for a graduate degree opens up even more doors. You see, at the end of the day, nuclear engineering isn't just a single job title. It's a toolkit for solving some of humanity's biggest, most important challenges. From powering our future to curing disease and literally reaching for the stars, these engineers are shaping our world at the atomic level. So the real question isn't just what do they do? It's what problem would you want to solve?